Hello everyone. So in today's class we'll be talking about image and speech processing. In that the specific topic that we are dealing with is the image compression models, right? So in today's class we'll be talking about Huffman coding and SHANO FANO. So what did we talk about in our previous lecture are like what are the image fundamentals, like what is the redundant data. That is, redundant data is data representation that contains repeated information or irrelevant information, right? Next we have said that what is the compression ratio. If compression ratio is equal to c by b by b dash, where b is the first representation and b dash is the second representation or the compressed model representation that we are going to study about, right? So compression ratio c is given by b dash. Next, if redundance ratio is given by r is equal to 1 minus 1 by c, right? So then we talked about what are the types of redundancy. We said that there are three types of redundancy. One is the coding redundancy, second is the spatial redundancy, and third is the irrelevant information. To remove the coding redundancy, we have said that instead of using fixed length coding, we are using variable length, right? So we are talking about the variable length coding. To reduce the spatial and temporal redundancy, we are having different coding techniques like predictive JPEG and all. So where the spatial redundancy, that is the same information which is conveyed by these pixels and its neighbors, is being reduced, right? Irrelevant information is also trying to be reduced. Next, we talked about the measuring image informations. What is the measuring informations we are talking about? We are talking about the information that is existing in an event E, right? So if we have an event E and the information that is existing in that event is given by 1 by log of 1 by probability of E, right? So here we are saying that if E is the event of occurrence of some intensity say R, then P of E is equal to the probability of occurrence of the intensity R, then the information that is conveyed by that information is equal to I of E is equal to log of 1 by probability of E, right? Next, the base of the log function will decide the units, right? Mostly we are using bits, right? We'll use bits. Next, we talked about what is the entropy of the image or entropy of a event, right? We said that if a source is of discrete set of possible events, then it is having probabilities P of A and all. Then the average information per source output, which we also refer it as entropy, is given by this formula, right? Here we are using the units bits per pixel, right? So here we are assuming that information is conveyed in the bits units, right? So this bits is the units for the information. If information is being conveyed in bits as the units, then the entropy is given by the bits per pixel, right? So we have to study about the different image compression models. So what are the different image compression models? There are two types. If we talk about compression models, image compression models, there are two types. What are they? First is error-free. Second is lossy, right? Or error-free, you can also referred as lossless, right? So there are two types of compression models, which is first is lossless and second is the lossy, right? Now, there are different types of lossless or error-free models which we'll be studying out. So in today's class, we'll be talking about two such models, which is the Huffman coding as well as the SHANO FANO coding, right? So what is Huffman coding if we specifically talk about? It is a coding technique by which coding redundancy is reduced. Next, this code yields smallest possible number of code or code symbols per source symbols. So what is that in detail? We'll talk about it when I'm explaining an example. right? So now it is a variable length coding technique also. Next, the minimum length code given is to the highest possible intents, right? So to reduce the redundancy, we are using the variable length coding technique, and how it is being dependent upon the probability of occurrence of the event or the probability of occurrence of the intensity value R. And here, if the intensity value is the having the highest probability, then minimum length code is given to such intensity or such pixel value, right? Now, what is the advantage of this? We are saying that smallest possible number of code symbols per source symbols are achieved, right? So how is this Huffman coding done? We will talk about while taking an example. Okay, before going an example, let me first talk about what are the steps to calculate the Huffman coding. So first step is we have to calculate the histograms. So while calculating the histograms, we will calculate what are the number of intensity values that are existing. Say suppose R1, R2, so on till Rn. So these are the possible number of events that are existing in our image, right? Possible number of events that are existing in our image. Then we have to calculate the normalized histogram. So what is the histogram? When we calculate the what are the possible number of events, we calculate the probability. Probability is given by the normalized histogram, which is given by the equation nk by mn, right? So nk by mn, where nk is the number of pixels which are having the intensity value R1, for example, and mn is the total number of pixels that are existing in our. How is the normalized histogram calculated? So the normalized histogram is calculated by nk by mn, right? So next, what will be the step? After calculating our normalized histograms, we will arrange the symbols, what are the possible number of symbols or the possible events, in the decreasing order of their probability. So we'll be ordering them in the decreasing order of their probability. Next, then we will first stage will be add the last two probability values, right? So and we go to our next stage. So when we go to the next stage, what we do? We repeat the step 3 and 4 until only probabilities which add up to give 1. So they should be, we will continue the step 3 and 4. We'll continue the steps 3 and 4 till we achieve the probability addition of 1, right? Then this is the steps 3 and 4 are called as forward steps. These are called as the forward steps. Next, what we do? We will start giving the codes. Okay, how do we give? The probability of the first symbol is greater than the probability of second symbol, then we give first 1 to the first symbol, then 0 to the other. Now, then we go from the end stage towards the first stage, right? So this steps is called as the backward steps, right? So we move to the previous stage and repeat the above step till we reach the first stage, right? So we do forward steps and then we do our backward steps. So while doing the forward steps, we will calculate the probabilities, right? We will go on add probabilities. In the backward stage, what we do? In backward stage, we try to code the symbols, right? So in detail, we will see with an example, small example here. So if we see here, there are the possible intensity values are A1, A2, A3, so on till A6. So we are going to use the Huffman coding. So what are the probabilities? It is being given in a table here. So if you see here, A1 is 0.1, A2 is 0.4, A3 is 0.06, A4 is 0.1, A5 is 0.04, A6 is 0.3. Now what are the steps that we have to do? First we have to calculate the histogram and the normalized histogram to calculate our probability. But in the given example, it's already probabilities are given. So we can just neglect the first and the second step. What does it say? Third step that we have to do? We have to arrange our intensity values in the decreasing order of their probabilities, right? So what will be, how do we arrange it? We get it in this form. So if we observe here, A2 is 0.4, so that will be the first one. Next, A6 is 0.3, right? So next, what do we get as A1, which is 0.1, A4 is 0.1. If you observe here, A1 is 0.1, A4 is also 0.1. So how do you, which should be placed before? That is of your choice. It can be placed, either A1 can be placed first or A4 can be placed. It is your choice. Next, so next comes here A3, which is given by 0.06. Next A5, which is 0.04. Right? Now, after that, what we do? We try to add the last two probability values. So what will be the next step of, or that we call it as the stage 1, right? So when we do, we add 0.6 and 0.4, and that is given as 0.1, right? So if you observe here, 0.1 value is, when we add the intensity values, we get 0.1. So if we order the intensity values in decreasing order, 0.1 is placed at the last. So it can even be placed at this point also, but for our convenience, we are adding at the last, right? So next stage, what it will be, we have to add this last two probability values. That is coming up to be 0.2, right? After adding, we are getting the value as 0.2. So if we arrange the intensity values in the decreasing order, so where should we place our 0.2? It should be placed at this point, right? So before 0.1, right? So after adding, ordering them in the decreasing order of the probability, we have placed it here. Now what will be the next step? We have to add the last two probability values, right? So that is given by 0.3, which we are placing at the end point. Next, we are adding this 0.3 and 0.3, which is coming up to 0.6. So this is the forward steps that we are, this is the forward steps, right? So first step would, in the forward steps, what we do? First, order the probabilities in the decreasing order, then add last two digits and arrange them again. After adding also, arrange them in the decreasing order and continue these steps till we achieve two probabilities, such that after adding, we get the probability, total probability as 1. So if you observe that, after adding 0.6 and 0.5, we are getting the total value as 1. So this will be our last stage, right? So the forward steps we have completed. Next, we have to do our backward steps to code our symbols, right? So after completing our forward steps, what is in the backward step? We have to consider the last stage, which is the stage 4 here. Now, if the probability of the first symbol or probability value of the first value is greater than the second value, so if we observe that 0.6 is greater than 0.4, right? So what we do, for 0.6, we give the value as 1, and for 0.4, we give the value as 0, right? So we code the values as 1 and 0 like this, right? Next, if you observe here, this 0.6, how did we get the 0.6? By adding these two digits, these two probability values, right? So if we go back to our previous stage, we observe that in stage 3, we have 0.4, 0.3 and 0.3, right? So 0.4 value is already coded and it is given as 0, right? So we can continue the same value as 0. Next, we have 0.6 value, which is coming as the addition of 0.3 and 0.3. So now how do we do? Both the intensity values are same. So we can give either it, but we will continue the same same policy, that if first one we are giving it as 1, the second probability value we are giving it as 0. So we are going to continue the same and we are going to give this as 1, 1 and 1, 0. So what is that? This 1 which we have coded in the previous stage 4, that we are shifting the bit by left side 1 by 1 bit, and after that we are adding for stage 3. If 0.3 is greater, so we are adding in the 1 value, and the next symbol we are giving the value as 0, right? So we observed here in stage 3, the coded values are 0 for 0.4 probability, 0.3 value, the intensity for 0.3 probability value is 1, 1. The other 0.3 value we have got it as 1, 0. Now, if you observe here, the 0.3 value is obtained by adding This 0.3 is obtained by adding these two symbols, right? So we have to continue our coding, right? So how do we do it? Say, so this 0.3 value, whatever code value we have got, 10, right? So 0.2 is greater than the 0.1 value. So what are we giving the code value as? 101, and for 01 we are giving it as 100, right? Right? Understood? Next, what we are doing it as the other 0.3 value, whatever is there, it is already coded and we are achieved it as 11. For 0.4, it is already coded as 0, right? So next, we'll go to our previous stage. So when we go to a previous stage, what did we observe? This 0.2 is obtained by adding these two probabilities, right? So from there we observe that 0.1 and 0.1. So either of them can be given as 1 or 0. So how did we do this? We have written it as 101, which is shifted by 1 bit towards our left side, and the upper value is given by 1 and the lower 0.1 is given by coded by 0, right? The rest of, now we have 0.1 here. The 0.1 is already coded as 100. So that will continue. 0.3 is coded as 11. 0.4 is coded as 0. Now, we have continued till the stage 1. Next, what we will do? We have to go back to our probability, the previous stage. Now, here, this 0.1 value is given by the addition of 0.06 and 0.04. So, what did we do? We have coded it again by continuing this number, right? So, that is given by 10, 10, 10, 10, which we have obtained it from our stage 1. Next, the upper value is given by 1 and this lower value is given by 0. Next, the rest of the symbols are already coded and we have obtained it in this way. So, if we observe here, let me just erase this. Now, if we observe here, now A2 is 0, A6 is 11, A1 is 100, A4 is 1011, A3 is 10101, A5 is 101000. So if I say, in my image, if I have my intensity value A2 here, so how do I code that pixel value as A2 pixel as 0? I have the intensity value here A6. So the intensity value A6, how do I represent it as 11? So this pixel value is coded as 11. Next, I have the pixel value, say suppose A5. So how do I represent this pixel value? I represent the value as 1011. 10100, right? So if I have in this way, I'll code my pixels, right? Now, then if we talk about our SHANO FANO coding, that is also variable length coding technique. Next, what is this code symbol? We have each symbol is based on the probability of occurrence. Since it is a variable length, so we are saying that based on our probability of occurrence, we are going to code our symbol. Now, what are the steps that we are going to follow? What are the steps? We are going to list of the probabilities and frequency counts. Frequency counts is the other word for the histogram, right? So, after that, what are the set of intensity values we are going to list out, right? Then what are we going to do? We are going to order them in the decreasing order of their probabilities. So this step is common. These two steps are very much common in Huffman coding as well as SHANO FANO coding. Later on, what are we going to do? In SHANO FANO coding, we are going to split the list into two parts. How are we going to split into two parts? The total probability of both the parts are close to each other. Say suppose our first part and second part, we have the, after dividing we have. So if the intensity value of adding all the intensity values which are probability values in the set 1 are turning up to 0.3, then the subgroup 2 should also similar to 0.3. It can be 0.2, it can be 0.25, 0.35, so on and so forth. The closest possible similarity is achieved. Then what do? We assign the value 0 to the upper half and 1 to the lower half, right? So we give 0 to the upper half and 1 to the lower half. Or you can do the vice versa also. It's not specifically that upper half should be always be given as 0. It can be done vice versa also. Next, what are we going to do? We are going to repeat the step 3 and 4 till when? We are going to repeat the steps 3 and 4 till all the symbols are split into individual subgroups. So what do you mean by that? If we have 6 possible number of probabilities or events that are existing in our image, then in that 6 we should have 6 subgroups that are going to exist in our image, right? So such kind of process is called as the SHANO FANO coding, right? So let me explain it with one small example. So how do we do that? We have the code word. Say suppose we have the intensity values A, B, C, D, E, F, G. Okay, we are going to use our SHANO FANO coding, and these are the symbols and these are the probabilities that are existing, right? So how do we do it? We are going to first rearrange them, and we are going to rearrange them in the decreasing order. So how do we do that? I order them as, if you observe here, they're already in the decreasing order. So what do I do that? I write them in the form of my table here, A, B, C, D, E, F, G, and so on, and their probabilities. Now the next step is I have to convert into 2 subgroups, or I have to convert them into 2 subgroups. I have to split them. So how do I do it? Such that after adding the probabilities, they're almost very much similar. So if I observe here, after adding these subgroups, I am getting my intensity values addition as 0.5. Right? The probabilities of here is given by 0.2 plus 0.1, which is 0.3, plus 0.1, which is given as 0.4, and here after adding these two, it is almost, we are getting it as 0.1. So these two probabilities are very much similar, right? So to one subgroup we are giving the intensity, we are coding the value as 1. For the other subgroup we are giving the coding value as 0, right? Next, what are we going to do? We are going to continue till all the intensity values are in single subgroups. So we are going for our second stage. Now what we do? We observe that these two probability values are in the single subgroup. So we are going to split them. So how are we going to split them? We are going to split them in such a way that the intensity values are almost similar. So we are going to divide it in this way, right? We are going to divide it in this way. Now, in stage 1, we have already coded the value as 1, right? So now what we do? We shift it by 1 bit towards our left side, and we observe and we give the upper subgroup as 1 value. And for the lower sub value, we are giving it as 0. So we have got it here as 1, 1 and 1, 0, right? Now, if we come to our below subgroup, we observe that we have 5 values. We have 5 values, right? And we have coded the 5 values as 0. Now we are going to divide it into a subgroup. So what are we doing? We are dividing it into subgroups such that their intensity values are almost same. So let me just, for my second stage, how do I do it? I am dividing it in this way. Why? If I add it here, I get the intensity values, probability values addition as 0.3. Now if I see here, after adding, I get the value as 0.2. Right? So they are very much similar. Right? If I try to take another other split groups, the intensity values are very much different. So what am I doing? So I am coding this value as shifting by 1 bit, and I am coding it as 0 and 0 and 1, 1. Right? Done. Now I am going to my stage 3. When I am going to my stage 3, what do I do? Go to my stage 3. If I observe my first subgroup is already split, and each intensity value or each symbol is already in a specific subgroup. So we need not continue anything. So this code values will be continued. Now if I observe in my second half of my code words, if I observe here, I observe that the intensity values have to be still be subgrouped, right? So I have the subgroup which I am going to divide it into another split subgroups, right? So I got it as 101 and the other is 100, right? So next, the subgroup whatever I'm having, I am dividing it as two subgroups. So I'm writing it as upper subgroup as 1 and lower subgroup as 0. So I'm writing it as 1 1 1 1 1 0. Right? Now, if I continue, I have to go to my stage 4 because they are still yet to be done. So here we have already got it as subgroups, right? Each intensity value is in my subgroup. Now here if you observe this code value to be further split. So I am taking it as 1101 1100, right? So at the end A symbol is coded as 11. So this is the symbol and my code word relation. So A is represented by 1 1, B is represented by 1 0, C is represented as 1 0 1, D is represented as 1 0 0, E is represented as 1 F is represented by 1 1 0 1, G is represented by 1 1 0 0. Right? So if you observe here, based on the probability, the code length is varying. If it is the highest probability, we have the lowest code word length, right? The similar thing is also observed in Huffman coding. So let me just go back. So when we have achieved in Huffman coding, what was the symbols? A2 is having the highest probability, it is having a single bit. Right? So A5 is the lowest probability value, which is having the 5 bits. Right? So it is a variable length coding as well as based on the probability of occurrence, we are coding. Right? So similarly, SHANO FANO coding is also the same. We have symbol represented by the variable length coding. So while doing, we observed here as Huffman coding and SHANO FANO coding. Right? So what did we do? They are mostly dependent upon the probability of occurrence. They are ordered in the decreasing order, and we have multiple stages where each step value is repeated. Right? So in Huffman coding, we are adding. Right? We are going to our forward steps. We are following our forward steps. Then in while coding, we are coming to our backward steps to our coding system. Now here what are we doing in SHANO FANO coding? In SHANO FANO coding, we are splitting the probability values into two subgroups and we are coding, right? So first stage is given. In first stage we will have two subgroups. Later on we will continue till all the symbol values are represented in each subgroup, right? So this is the book that we are referring for Rafael Gonzalez for our image compression models. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.